Hey guys, welcome back to my channel. Today we're going to be making 5 physics projects. 2 of them are DIY and need cutting and stuff, and 3 are things you probably have. So let's make them. This first one is pretty simple. I call it the surface tension boat. So all we're gonna need is some scissors, construction paper or card, water, and a shallow dish or plate. So for now, we can remove these. So now we should cut this construction paper into sort of a rectangle with a triangle cut out of it. There's a link in the description which will take you to a document in which you can print it out for free and it will help you. So let's get cutting. That's our construction paper done, and that's our scissors done. So now bring back the water and the plate, and now just pour some of the water. We need a Q-tip and soap for this one. I forgot to mention that. So take your soap bottle, dip your Q-tip, don't soak it in too much. Put this in, it's just floating. Now put this in, and it goes. But if you do this too much, it will not work. So just change the water from time to time. So this works because the soap breaks the water tension of the water and it goes in like a circle way, and the boat happens to be in the way, so it just gets propelled on. So now that's the first experiment done. Now time for the second one. So for this, you're gonna need a plastic bottle, double-sided tape, a straw, another straw that perfectly fits in this straw, some cardboard, some tape, and scissors. So I call this a straw rocket. So yeah, if you squeeze this real hard, this part is gonna be a rocket, just gonna go flying. So yeah, let's make it. So first, screw the cap off, and actually you're supposed to make a hole here, but it's not safe to make a hole right here. So I made it before, and yeah, that's a hole that perfectly fits this, mind I tell you. Oh, it's a tight fit. So I finally got it to fit. Now this is just gonna be placed like this, and this is gonna be put in here. So this is just for measurements, so that we don't screw up. So yeah, it's supposed to be like this. So I marked these fins on the cardboard. Now we're supposed to cut it. I finally cut the fins, so now we're supposed to put this in, and 1/4 of the way, and then remember where it's supposed to be, and fold this. Take some double-sided sticky tape and place it over here like this on the bended part, and then just stick it on the straw. This will work even better if it's plastic. So the fins are on here. Now we're supposed to put this here, and we're supposed to take some more double-sided tape, and we're supposed to put it on here so that it makes an airtight seal. Here I think you're supposed to give more hot glue, and here too, but I don't think that's necessary. This is just the right fit. So yeah, plug this up, and then you're supposed to give it a sharp jolt. 3, 2, 1. Okay, round 2. That was so cool. 3, 2, 1. Oh my god, that went so far. This happens because When we squeeze the bottle, air pressure inside it increases and it wants to escape any way it can. So the only way for it to go is down the straw, up to the rocket, but remember, we plugged the top of the rocket straw. So it's just gonna go up and propel the rocket upwards. So this is a DIY version of the greedy cup. You're gonna need water, a bottle with its bottom cut off and the cap has a hole, a straw, a test tube or anything similar, and a plate. So first, we are gonna put straw through the hole. Oh god, sorry. Or you can just remove the cap and do it. It's easier. And then screw the lid on. Pull this through. Add a test tube. Oops. Add a test tube and push it up until it's about the height of the test tube. And that's almost it. And now you're supposed to take the water. I'm actually gonna screw the cap and open this so it's a steady flow. And look at that. I haven't put hot glue on the bottom, so it's leaking a bit. But after I go atop the height of the straw, it's gonna start leaking everywhere. Fun fact, did you know that lasers can cool things? This seems counterintuitive because lasers are heat source and they can heat things up. But if you place 6 lasers at every 6 degrees of freedom and an atom happens to be in the middle, it stops moving and then it cools down because things that are not moving are really, really cold. Have you ever wondered how many drops of water can fit on a penny? If you haven't, take a guess right now because it's probably much higher than you think. And this experiment is going to prove it. So all we're going to need for this is some water, a dropper, and a penny. So, take the water and I'm going to drip it. 1, 2, 3, 4, 5, 6, 7, 8. I'm gonna move the camera closer so you can see. So the camera has been moved closer. Hopefully you can see the penny. And right now there are 8 drops on there. So let's continue. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, 19. Okay, let's try again. Okay, try 2. 3, 2, 1. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, again 19. Okay, we got 19 drops on both of the tries, but I don't think it's gonna be 19 every time. Maybe just for that one penny, but pennies differ. So I think it might be actually 15 to 20 drops. So this works because when all the water is on the penny, which is a small surface, and there's a lot of the water, it beads up and makes sort of a dome shape. That's called water tension. Okay, now for the 5th and last experiment. For this one, we're gonna need some soap, some water, only a little bit this time, and something to flick the water. So first, let's pour our water, only a bit. This is enough. And take your soap, only a bit, and pour it in. Oh, I poured too much. And just mix it in. Mix it in. Bubbles are gonna come, that's normal. And just flick it. Oh, that's so cool. Okay, so hopefully you can see the water. And just, I'm flicking it. Look at that, there's an anti bubble. Or you can just drop the water from a height, or just flick it. Look at that. That's so cool. all of those that are forming, they don't look like bubbles, like that and that. They're actually anti-bubbles. Oh, that's so cool. But they don't last for very long. So this happens because when anti-bubbles are formed, there's water as a bubble, air in the middle, and water on the bottom. So the soap kind of makes it easier, and we can just flick it and like it falls, but air is in the middle and there's turbulences in the water, so it forms a bubble of water, which is super cool. If you like this video, hit that like button and smash the subscribe button. There's a video on the screen somewhere which you might want to watch. Tune in next time for more amazing experiments. Bye bye.